In this video, we will look at how to use the frequency analyzer in LoliTrack 5. First, we will see how to make the software find frequencies and how to quantify heart rate in a mahi-mahi larvae as an example. Next, we will use the structure analysis function to estimate the stroke volume in the same larvae. Finally, we will show you how to use the software for finding the tail beat frequency in a Brazilian fish, B. amazonicus, during swimming. All typical examples of frequencies and all done directly in LoliTrack 5. Once you enter the frequency analyzer from the main menu, the first thing you'll do is to open the video you want to analyze. Here we have a video made by Professor Martin Grosel from the University of Miami showing the oscillating heart of a 48 hours post-fertilization mahi-mahi larvae. This is actually a demo video that's included with LoliTrack 5, so feel free to follow along and try this for yourself. The frequency analyzer is useful for when you want to analyze frequencies or repeating patterns in a video. And to find the optimal area for the analysis, you'll want to look at areas where the pixel values are changing the most and most consistently. Here, if we drag the marker on the timeline, we can see that the edge of the heart is oscillating with what seems like a specific frequency. So we simply left-click and drag to mark an area around this point. And this looks good. Next, we'll click Generate Signal. But before we do that, it's worth knowing that you can input the expected frequency or beats per minute value. Inputting this value will help the analysis, but if you do not know the expected value, just leave this field empty. LoliTrack is now analyzing the selected area, and once the analysis is done, we'll see the signal strength graph in the lower area of the screen. The signal strength graph shows you the deviation from the mean of the pixel value. In other words, a perfect frequency will show up as a sinus curve, so you'll generally want to look for these types of curves. This here is looking pretty good. To get more details about the analysis, click Analyze. The pop-up window shows you quite a bit of information. First, you'll notice the now estimated frequency value. The analysis shows us that the heart rate of the mahi-mahi larva is 203 beats per minute. If we take a look at the three graphs on the left, we'll first recognize the top graph from the previous screen, the signal strength graph. Again, the more sinusoid the curve is, the cleaner the frequency is, and the more precise your estimate will be. The middle graph shows you the estimated change in beats per minute over time. In our video, the beats per minute is more or less constant around 203, but in other videos, you may see that the beats per minute are changing throughout the video. For example, if the heart has been affected by an external stimuli at a certain point in the video. The bottom graph shows you the clean Fourier analysis, which is an estimate of which frequencies the signal consists of. Here we can see that our frequency consists of mainly frequencies at around 203 beats per minute or around 3.4 Hz. Each graph can be exported to Excel either individually via this little menu or using the Export to Excel button, which will export all of the graphs. Going back to the main window, we can now move on to the structure analysis. Analyzing structures is similar to analyzing frequencies, except that we can include the depth parameter to estimate volumes, like the stroke volume of our larvae's little heart. First, you'll want to make sure that the ruler is set correctly. Simply measure out an object or feature of known length in the video and type in the distance, here in millimeters. Next, you'll want to input an expected frequency value. So a great tip is to perform a frequency analysis first, like we just did, and then input the result in this field. The principle in the structure analysis is that we outline a specific structure using points and lines for each frame in the video. To do this, click the Add Point tool and click on the video to outline a structure, here the heart. Notice that you can switch tools to remove points or to adjust a point. Once you have your outline, go to the next frame. Another tip to move easily between frames is to hover the mouse over the timeline and then use the arrow keys on the keyboard to move between frames. In the next frame, you'll want to choose the Adjust Point tool, and then click and drag each point to match the structure that should now have changed its shape. You can also add or remove points if needed. Repeat this procedure for at least one whole cycle, like one heartbeat. But notice that the more frames and points you create, the more precise the analysis will be, but the analysis will also take a longer time to finish. Once you have created the perfect structure outline for each frame, remember to save the outlines. We have already analyzed this video, so I will load in an example structure. I have outlined 2 whole cycles, and as an example, I will run the fitting procedure for just the first second in the video by holding Shift, left click, and then dragging on the timeline to mark out the interval. You will now see the fitted points and area which are based on the points you've created. One thing to note is that the blue points are the annotated points, which can be controlled with the tools. The nearest structure points are red and shows you the last known annotated points on the timeline. And the white points are the fitted points. I think this looks good for now, so I will perform the structure analysis. But note that you can always go back to a frame, adjust the outline points, and then run the fitting procedure again. A pop-up window shows up with 3 new graphs. The top graph shows you the estimated area of the fitted area over time. The middle graph shows you the estimated volume of the area. The volume calculations are based on the value you input in the depth field, here the depth of the heart. One limitation is that LoliTrack assumes the depth is constant over the entire area. But if you switch on the scale depth dimension, the software will add a factor to the volume calculations that assumes that the height changes when the width and length of the fitted area changes. Like when a heart contracts and relaxes, the depth of the heart will change as well. The lower graph shows the maximum, minimum, and estimated stroke volume over time. If you want to change the look of the graph, you can always do that here. And with the frequency analysis, we can export all of these results to Excel. In this last part, we will look at the tail beat analysis function. This is a frequency analysis that is especially good for calculating tail beat frequencies in swimming fish. Let me show you why. In preparation for the analysis, I have tracked a swimming fish video created by Dr. Marcio Ferreira from the National Institute of Amazonian Research in Brazil. And I have included a simple midline. Moving on to the Analysis tab, we can open the Bend subtab and find the Frequency Analyzer in the lower right corner. This frequency analyzer is a bit special since it uses the bend graph of the tracked video of our fish that is moving around in the video. The frequency analyzer in the main menu needs the object to be stationary throughout the video, but this is not needed here. So, in other words, if you need to calculate tail beat frequencies, use this tool. Again, you can analyze the entire tracked video, or you can just go to the Settings subtab and choose an interval for the analysis. And if you know the expected frequency, input it here. Otherwise, just leave the field empty. The pop-up window is then similar to the analysis window found in the frequency analyzer in the beginning of this video. So I will not go into more details about it here. But from the analysis, we can see that the estimated tail beat frequency is 8.20 Hz. Again, you can export these results to Excel. And this is it for the frequency analyzer in LoliTrack 5. Feel free to contact us if you have any questions.